All right, here we go. I got students in the room right now, but I guess they're content being heard over the video. So this is Mr. Canfield. We're going to go through the second page of the GeoGebra coordinate problems. Good job. So this first question says, prove this is a right triangle. It's supposed to say prove this is not a right triangle. All right, good start. Let's zoom in a little bit. So we're just trying to look and see if any of these is a right angle, then it's a right triangle. This looks like a right angle to me. The way we prove that is by looking at the slopes. So I go 1, 2, 1, 2, 3, 4. So my slope for this line is 2 over 4, which, just a reminder, 2 over 4, we can use our calculator. That simplifies to 1/2. Then if we look at this one, this is supposed to be the opposite reciprocal. If it is, then it's perpendicular. It's a right angle. If I check it out, though, 1, 2, 3, 4, 5, 6, 7. Ooh, that was fancy. All right, 7 down, so that's -7. And then 1, 2, 3 over, -7 over 3. So are those opposite reciprocals? Well, one's positive and one's negative, but they're not the same numbers flipped. So that is not perpendicular. Are there any questions on that? Do you have any questions with what we just did? Like that, if you're trying to prove something is or isn't a right triangle, that's all you have to do. You just look at the slopes. If they're flips and one's negative, boom, done. I'm filming this for all of you napping right now because can't help you during the test. All right. This one says, prove that this quadrilateral is not a rhombus. So just a reminder, rhombus, the idea was all sides are congruent. So I'm going to write all sides equal. So I don't know if you can see this looking at it. When I look at it, one of the sides looks kind of weird. So what I'm going to do is I'm going to compare 2 of the sides. Yeah, it's picking you up, just so you know. I mean, as long as you're fine being on my weird YouTube channel. All right, so this side to me looks kind of funky. I'm going to check this one out. If I look along the bottom here, 1, 2, 3, 4, it's 5 spaces. And then I look along the side here, that's 3. So it's 5 and 3. I don't need to know what the third side is. I just know that those 2 sides are 5 and 3. There's a unique third side that comes from those. So if I get 5 and 3 for all my other ones, that actually would be a rhombus. If it's 5, 3, 5, 3, 5, 3, that would be, because that would mean all the sides are going to be equal. What color should we do? Green? All right. If we do green, if I check out this side, 1, 2, 3, 4, 5. Oh, it's 5 again. Is it 5 and 3, though? 1, 2, 3, 4. So that alone is all we need to say this is not a rhombus. If we were trying to say this was a rhombus, I'd do the same kind of thing. I'd just show it was the same all the way around. I don't even need to know what the numbers are, like what the actual side lengths are, just that it was the same. If I thought it might be a parallelogram, I could show parallel by showing those same sides from earlier. Anyone have any questions or anything on this second one? So I am going to be asking for proving like this on the test. I wouldn't just write this. You'd need to say something along the lines of like, since the triangles are different, the sides will be different. So not a rhombus. that's one way you could word it. I think there's dozens of ways you could word this that would be appropriate. So I'm not going to say that's the way you have to word it. So that's number 2. On to number 3. Prove whether or not this one is a trapezoid. I'll remind you for trapezoid, two opposite sides are parallel. 2 other sides are not. So if I'm trying to figure out whether or not this is a trapezoid, it's all about the parallels. So I look at A to B and I see it goes up 1/3. So A to B's slope is 1/3. D to C better have the same slope if it's going to be a trapezoid. Let me check it out. 1, 2. That's not a good sign. 1, 2, 3, 4, 5, 6. 2/6. So I had 1/3 and 2/6. But I can use my calculator. 2/6 simplifies to 1/3. So those two are parallel then. And then the other ones, if I look at these guys, this one right here, AD and BC, do we feel like those are parallel? Like, I would be fine with you saying those two are clearly not parallel. If you're trying to tell me that something is parallel, you want maybe a little bit more evidence than that. But like, they're going to touch up there. So not, I'm going to say yellow because I used yellow. So we had the two that are parallel, the two that are not parallel. That means trapezoid. Also, I accidentally made an upside down traffic light. I have green at the top, yellow in the middle, and red at the bottom. I don't know why I picked the colors like that. Okay, so that's that one. And then 4. I had a little bit too much fun making 4. It says point J is the midpoint of AC, which if I look here, I can either use the midpoint formula or I can just kind of count it. I can come in 2 from both sides and go up and down 1. So that's point J. Then it says point K is the midpoint of FH. So that's over here in the other shape, in between F and H. And it's actually the same kind of thing. They're 2 spaces apart horizontally, so I'll go 1 space. And they're 4 spaces apart vertically, so I'll go 2 spaces. You can just kind of eyeball it. If I was trying to use evidence, I could always say, well, this is at like 8.5. This is at 10.1. And I could use the midpoint formula, which says you add up the x's, so that'd be 8 plus 10, and you divide them by 2. So 8 plus 10 is 18, divided by 2 is 9. So our x coordinate would be 9. And then our y coordinate, you add up the y's and divide by 2, which is 5 plus 1, divided by 2, which is 6, divided by 2, which is 3. And that does match this point right here. So that would be a way to do that with evidence. It says, the question actually asks, what is the length of JK? Anyone in the room need me to pause for a minute? All right, and I'm uploading this as soon as I'm done filming it too, so you will have access to it. I wanted to help you all individually if you needed it. Is seafoam, is that visible? That's pretty visible on the board. We use this nice seafoam green. it wants to know the distance from J to K. From just to kidding. So you could use the distance formula. You also could go and say, well, I look along here, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. And then I can go along this side here and see it's 1, 2, 3, 4 spaces. And that diagonal there is the distance. So I could say 4 squared plus 10 squared is equal to c squared. We don't know what that side is, but that would be the distance. And we could type 4 squared plus 10 squared in our calculator, and it would give us 116. A little bit of space. Let me zoom in. So that'd be 116, and that would be equal to c squared. So if I want to find c, I'll just take the square root. Square root of 116 is 10 point, I forget. Anyone? Oh wait, is it on my paper here? Nope, I don't have it on my paper here. I just have square root of 116 with a little arrow pointing down. 77? 77. So if you're going to round it to the first decimal place, the number after that decimal place tells us to round it up. So you write 10.8. People in the room, anyone got any questions on that? People at home, you got any? No, just kidding. What a weird world it would be when we can reply to, oh wait, never mind, that's streaming. That happens already. All right, number 5, and then we're done reviewing for the test. For quadrilateral ABCD shown above, prove all types of quadrilateral it belongs to. So to me, I think it's a parallelogram. That's what I see. It kind of looks like a parallelogram to me. So the first thing I'm going to try to show is that we got 2 sides parallel. I think these 2 are parallel. They both go down 2 over 2. Down 2 over 2. Yep. So that means AD and BC are parallel. Why am I writing this by hand? I have a little typey thingy I can use. Does that make sense? We good on that? Why those 2 have to be parallel? So then the next thing we can see that AB and DC both go up 4 over 2. So they are parallel. That's another way you could show that. That's me kind of proving my case there. Parallelogram. So I typed, the counting I did also shows the side lengths of the parallel sides are congruent, so it's a parallelogram. I think it's a little wordy, but that's the way I thought to say it right now. You could use different words. I'm not looking for any specific wording on this. I want to see if you can kind of reason out with me and explain it to me. So, yeah, I hope this video was helpful to you. Bye.